All right, in this learning objective, we're going to learn another way to solve quadratic equations. All right, so far we've learned two ways to solve quadratics. All right, we learned about factoring, and then we were able to use square roots. All right, but these strategies are not going to work for every single quadratic. All right, not every quadratic can be factored, and not every equation makes sense to use square roots. All right, but what happens if we get a quadratic equation that doesn't fit into one of those categories? All right, we're going to use this new strategy called completing the square. And the idea of completing the square is we want to be able to use that square root property that we learned. So if we can make something like this in our equation that has this perfect square, then we can do everything we did in our previous learning objective of taking square roots and moving things around. The only problem is if I just make up some random quadratic, this does not look like that. All right, so that's the problem, and this is what completing the square is going to help us with, is figuring out how can we turn this equation into an equation that looks like that. All right, so to do this, we're going to look at these two things being squared. Again, squared is the important part because then I can use square roots to get my answer. So x plus 2 squared, I remember from our lesson on FOIL, this means you're multiplying it by itself, so I have to FOIL this out. So x squared plus 2x plus 2x plus 4 is x squared plus 4x plus 4. All right, so that's x plus 2 squared. What about x plus b squared? All right, b is just another variable. All right, so we do the same thing. We get x squared plus bx plus b squared. X squared plus 2b plus b squared, 2bx. Right. So here's what I kind of want you to recognize. So first, let's look at the b ones. All right, when I have this thing written out in the long form, the middle term is going to be double whatever that number is. And the last term is the square of whatever that number is. So let's make sure that works for when we actually had a number. All right, this number is double. 2 times 2 is 2. And this number is the square. 2 times 2 for a different reason is also 2. All right, so we're going to use this to our advantage. All right, when we have a perfect square, this number is double what goes here, and this number is the square of what goes there. All right, so let's see how that's going to help us when we complete the square in a problem. All right, so here's what we're going to do when we complete the square. All right, the first thing I'm going to do is I just want to get the x squared and the bx part by itself, all right, because that's kind of all I need to complete the square. So the first thing I'm going to do is add 3 to both sides. I'm going to leave a gap here, and we'll see why. So my goal now is to turn this left-hand side into a nice, perfect square. And to do that, we're going to need to fill in, this is why it's called completing the square. I need to fill in this blank with the thing that's going to make this a perfect square. And this is where we're going to use that last slide to help us. We saw on the last slide, this number is double the perfect square number. So if I take 4 and divide by 2, that gives me 2. That should tell me that I'm trying to make my equation be x plus 2 squared. And we also saw that this piece here is the square of that number. So if I square that number, this should be a 4 there. So I had to put a 4 in this box, but I'm looking at an equation. So before this equation, this 4 is in here, which means I also need to add a 4 over there. So now my equation becomes x squared plus 4x plus 4 equals 7. But that left-hand side we generated for a reason, because that left-hand side is x plus 2 squared, exactly x plus 2 squared. And now this equation looks exactly like the ones from the previous learning objective. I had this square all by itself, so I can take the square root of both sides. X plus 2 equals plus or minus the square root of 7. The square root of 7 doesn't simplify, and I subtract 2 to get my final answer. All right, so we're going to do more examples of this, but this is the idea of completing the square. You kind of start with the first 2 terms of your quadratic, and you figure out what do I add to it to make this actual perfect square. And we're always going to use half of that b number, all right, to help us do that. All right, so let's do some more examples. x squared minus 8x plus 10 equals 0. Again, the first thing I'm always going to do is subtract 10 because I like to have these first two terms by themselves. All right, and I'm always going to leave a gap because I'm trying to figure out what am I going to put here to complete the square. All right, so what I'm going to do is I'm going to take this negative 8 and divide it by 2 to get negative 4. So this tells me my answer is going to end up being x minus 4 squared. But what's going to go in this section that I'm missing? Well, it's whatever this number is squared. So now I take negative 4 and square it and get positive 16. So I'm going to put a plus 16 there. And since I'm kind of adding a plus 16 to one side of my equation, I also need to add it to the other side of the equation. So I have x squared minus 8x plus 16 is equal to negative 10 plus 16 is 6. All right, but again, the whole reason of doing completing the square is this left-hand side, which I kind of just made, is exactly a perfect square. Actually, this is the completing the square part. I make this first blue box so that it turns into a thing being perfectly squared. And that's useful because now I can take the square root of both sides. X minus 4 equals plus or minus the square root of 6. The square root of 6 can't be simplified, so I just get 4 plus or minus the square root of 6 as my final answer. All right, so figuring out what this number is, so this is pretty much what completing the square is figuring out what this number is that turns my non-perfect square thing into a perfect square. All right, so that's what I mean by completing the square. All right, I'm going to do one more example. Oops. Again, I like to get these two terms by themselves. And then let's see. So we're going to take that middle number, or that b number, and divide it by 2. That gives 3. That's going to end up being our answer. But to get what we get in that box, we square that number and get 9. So I'm going to have to add 9 to make this a perfect square. Again, since I'm adding 9 on the left-hand side, I also add it on the right-hand side. And again, the reason we did that is because now this left-hand side is going to be x plus that number. So x plus 3 squared equals negative 1. Now I can take the square root of both sides. X plus 3 equals plus or minus the square root of negative 1. And remember back to our square root videos that this means this has no solution. Now, for right now, we can't take the square root of a negative number, so we just say that this has no solution. All right, here's one for you to try on your own. All right, guys, so think about the process of completing the square. All right, what number do you have to add in order to make this thing work? All right, so my first step, I add 3 to both sides so I can get the first two terms by themselves. All right, negative 2 divided by 2 is negative 1, so that's going to end up being the answer there. Negative 1 squared is 1, so that's the number I need to add to complete the square. So I add 1 to both sides. Then I can take the square root of both sides, and I get this equation. Add 1 to get here. And in these cases where the square root goes completely away, I can actually figure out my two full final answers. So if I choose the plus sign, 1 plus 2 is 3. If I choose the minus sign, 1 minus 2 is negative 1. All right, so these are my two final answers down here using completing the square. All right, so completing the square is kind of a weird one to get used to. All right, but if you practice, you're going to figure out kind of the pattern of your kind of answer number is that b number divided by 2. And the thing you actually end up adding to your equation is that number squared. Right, but if you look through the videos and do the practice, I think you all can get there.